Hello, my name is Appeltans and I will present the OBIS we need for the ocean we want. This presentation is based on a stakeholder consultation that we did a few months ago. For 22 years now, we have been building a central global data platform that provides free access to the world's ocean biodiversity and biogeographic data. I think it's fair to say that we have built up a solid reputation, especially among the scientific community. We provide access to more than 80 million observations of 157,000 marine species, integrated from over 4,000 datasets. Last year alone, we added 20 million new records and 100 million measurements or sampling facts. This sounds amazing, but maybe this is just the top of the iceberg. In a recent study, a survey of around 300 long-term biological observing programs revealed that only half of them store their data in a long-term data repository, and only a quarter provide public access to their data. The most common argument is that they don't know how to publish their data in OBIS, or there are no resources to cover that extra step. In a recent European microalgae workshop, 20% of the participants admitted that the only copy of their data is the one that they have on their computer. Another issue is that a lot of marine data in GBIF is not in OBIS, and a lot of the data in OBIS is not in GBIF. Gladly, we do have a good cooperation with GBIF, and GBIF now has made it possible to indicate that a dataset can be published in both GBIF and OBIS. So there is now a single publication process to OBIS and GBIF. This discrepancy between OBIS and GBIF should become smaller in the coming years. We realize that our data systems are not well connected to decision making, which means there is little incentive or mandate to publish data in OBIS. It would be very powerful if governments would start making management decisions on the basis of OBIS. So why is this not happening? We have not yet managed to develop a system that systematically monitors the change of biodiversity. There are tons of research papers predicting the effects of climate change on the distribution of species, but detecting and reporting the change is still in its infancy. And we remain mostly at the level of biodiversity description, as illustrated in the many international and UN-led assessment processes to which OBIS actively contributes. The Convention on Biological Diversity, or the CBD, is also using OBIS as one of the primary data and information sources for the identification of EBSAs, the ecologically or biologically significant areas, and OBIS provides biodiversity indices to those regional workshops. But then there is the recent Global Coral Reef Status Report that did not use OBIS, and they could not release the underlying data either. Things might change under the CBD post-2020 Global Biodiversity Framework, where several new marine biodiversity indicators and targets are proposed, and which countries will need to report upon. For OBIS to play a role, it will be very important to build trust and provide indicators on completeness and reliability. Develop targeted information products based on decision grading criteria and with an indication of fit for purpose. I am looking forward to seeing co-design, co-development workshops as part of the UN Ocean Decade programs to help us in developing policy-relevant statistics. But then there's a question of where does the role of OBIS start and end in the value chain from observation to decision-making. Our core mandate is still making data fair and develop that capacity in our community. And we need to develop partnerships to make the connections with the other ends of the spectrum. In terms of findability and accessibility, since we run a new technology stack, OBIS has a very powerful portal to map, filter and download millions and millions of data. We have an API which powers third-party applications that are directly connected to our system, and many scientists are running analysis on OBIS data on their desktop using the ROBIS package. There's a lot of work to do in making the data in OBIS interoperable. A lot of that work means mapping the measurement types and units with controlled vocabularies. An OBIS task team is looking into this. We perform 21 QC checks on every record, and every record receives QC flags, which provides a measure of accuracy. We provide tools and training resources, and in collaboration with the Ocean Teacher Global Academy, have organized 24 in-person training courses. Our goal is to publish at least 50 short online tutorials by the end of this year, so nobody will ever say again that publishing data in OBIS is too difficult. To survive, OBIS needs to expand its scope, especially with novel technologies like imaging, and we only just started dealing with genetic data. We will also need to think about disease factors or pollution and other stressors to biodiversity data like underwater noise, acidification, oxygen reduction, etc. In 2017, we introduced a new extension to Darwin Core standard called the Extended Measurement or Effect Extension. This has allowed us to capture biotic and abiotic measurements, as well as document all the sampling facts. The possibilities are endless, and we really are at the beginning of a new era for OBIS. We already added 100 million measurements last year. The reputation that OBIS is only about presence data is very, very sticky, but this is incorrect. We have always captured information on abundance and biomass, and are now adding data from genetic sequences, tracking, as well as habitat cover. The collaboration with the Global Ocean Observing System, GOOS, and the Marine Biodiversity Observation Network, or MBON, is key to develop data specifications for the essential ocean variables. We know that communication and outreach is still too weak in OBIS, but we are working on building and engaging with our community through our Slack channels, Twitter, Facebook, and YouTube. We are also developing forces in the field, like setting up an early detection system of marine invasive species in Fiji using environmental DNA. The data processing and bioinformatics pipeline is part of OBIS. And we are now expanding the eDNA story through UNESCO expeditions in marine World Heritage sites. There are still 5 blockers for making progress, and removing those would be big game changers. First of all, the lack of a strong global agreement to making our publicly funded biodiversity research and monitoring data public. If we do not change this, we will always play in the margins of oceanography. We need more standardization in our protocols. Everyone is doing things their way, and it will be very difficult to change habits. But as long as we do not measure biodiversity in a coordinated way, we will always compare apples with pears. We have not yet managed to identify and develop clear and effective pathways to reach and engage with our stakeholders. We need to grow up and move from scientific experiments to a mature operational observation and forecasting service. Like a Met Office for weather, we also need an Office for biodiversity prediction. We do not like to say it, but competition is fierce. Every new short-term contract is used to develop yet a new system for which there is no money to maintain it further, while the existing systems struggle to survive. We need to start pooling resources and work together in a much more agile way. We don't want to rob a bank, but governments need to become serious in funding the national OBIS nodes. OBIS is as strong or as weak as its network of OBIS nodes, and the majority of them do not have any structural funding. With a good team, with a good teamwork, we make it happen, and I wish to thank the donors for all their support.